Hi there everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we're going to be learning about speed and the equations associated with it. We're also going to be looking at how we can graphically represent speed on a distance time graph. So if you do find this video helpful, feel free to give it a big thumbs up so I know, share it with someone else, and also subscribe if you haven't already. Thank you so much for all your support. It's lovely to have you here, and let's get started. So the first thing you need to know is that speed is actually defined as the rate of change of distance. And if you ever see in the exam the word rate, it's just talking about the change in something in a given time or how long it takes something to happen. And that's exactly what's going on when we talk about speed, okay? And speed is often measured in meters per second. However, as you know, we may have miles per hour or we might have kilometers per hour. There's loads of different ways of expressing speed. But for your GCSEs, it's really important to be aware that actually meters per second is the most common unit. Distance, of course, is measured in meters and time is measured in seconds. And if you ever get asked in the exam, what is the unit? Express your answer and give the unit, and you can't remember for whatever reason, always look at the equation, especially if it's a simple one like this, where there's not too many different components to it. You can always work out the units from the equation. So speed, you can see, is distance divided by time, or meters divided by seconds, or meters per second. So that's where the units come from. Now, you need to be aware of the equation, yes, of course, and the units. However, you need to be able to manipulate the equation and actually utilize it in different ways. So maybe if time is the subject or distance is the subject, you also will be expected to convert your distances and time. So being aware of those key mathematical skills in science, it can make up to around 10% of your exam. So it's really worth knowing those bits of science and maths in and out. So if you would like some extra help, or perhaps even I could make a video all dedicated to maths for science at GCSE, definitely let me know if that's something you'd like, and I can make that for you. So how do we actually calculate speed? So we know the equation, first of all. We know that speed is equal to distance divided by time. That's great. However, we need to do some examples. And with any kind of calculation in science, I'm going to say this forever and ever, I envisage. I always say this in real life, but also just on YouTube as well. If you type it, you must write it. So if you type it in your calculator, please write it down on your piece of paper as well, because like I always say, if you make a mistake in the exam, you accidentally put the wrong number, you miss out a decimal place, whatever the case is, having a track of what you've actually tried to do, you can sometimes still pick up marks. So be careful when you are using a calculator. Just remember, if you type it, you must write it. So let's have a go at a question. Okay, a cat is playing with a ball of wool and it rolls 3 meters across the room in 0.2 seconds. Calculate the speed of the ball. So this is quite a straightforward question, but it's worth doing anyway. One thing I would mention, if you're struggling with calculations in science, I recommend getting your pen or whatever you're writing with and circle the key points to it. Okay, then what you want to do is write your equation out. So I have speed equals distance divided by time. I then put my numbers in. So 3 divided by 0.2. If you're not sure which way around this goes, of course, you want to look at your units, okay? Always make sure as well, the units that you're expected to express your answer in, you don't need to do any conversions. And in this case, we don't, so we're all good. If we do 3 divided by 0.2, we get our answer of 15 meters per second. And I've underlined that. However, in your exam, there's often a space to put your answer. So just make sure you put your answer in the correct area. Have a go at this next one. It says the cat chases the ball at a speed of 20 meters per second. The cat runs slightly further than the ball to a distance of 4 meters. Calculate the time it takes. Do comment down below, show you're working out, and if you'd like the solution to this question, I will leave it in the description box for you, as always. Okay, so how do we represent this sort of data on a graph? Because that's one of the key components to this topic and just science in general. It's how we display and share this information graphically. Because realistically, it's great to see lots of numbers, lots of data, but actually to present our data in a graphical form, it kind of paints a nice picture of what's going on. So you'll see loads of different graphs along the way in science, but physics particularly likes to have a lot of graphs in it. So the one thing I would recommend, if you ever have to draw a graph in science, specifically in biology, but sometimes in chemistry and often in physics as well, you don't always have to use a ruler if the data shows a general curved flow. So if the data is showing a flowed that's kind of, curving around, you don't often have to use a ruler. However, if you can see a nice linear line, I highly recommend using a ruler. And if you'd like extra support with maybe graphs and things like that, again, I can always make another video on this dedicated to graphs. Just let me know, and I can get that sorted for you guys. The other thing to mention as well, if you're doing the higher and triple science content, you will potentially be expected to draw a scale. Just be very careful with how you draw your scale, and you are consistently going up in the same increment each time. So if you've gone from 0 to 5 to 10 to 15, you don't suddenly jump to 100. Okay, you're going up in the same increment. That's just something to be aware of. So when you see a distance time graph, we have distance along the y-axis, and that's in meters, and along the x-axis we have time. That means the gradient of that line is actually going to be the speed. So we could calculate the speed if we wanted to. If there's a curved line, which you can see in the green and the red, we'd actually use a tangent of that curve and then use the gradient, calculate that using the tangent to work out the gradient as well. Okay, the green and the red lines are slightly different to the blue line, so I will mention this first. The green line is actually curving downwards, and that indicates that the speed of the object that's moving is actually decelerating, so it's getting slower. Whereas the red line is actually increasing and it's actually accelerating. And that means it's moving at a faster speed every single second. Acceleration and deceleration is measured in a slightly different unit, and this is in meters per second squared. So just be careful about those units for those quantities. In terms of the blue line, this is where you're going to more likely see the typical kind of data here. So for example, as you can see in the blue line, the first part of that line is going straight up in a linear line, and this tells us that the object moves quite quickly. The object then will stop, and we call this a stationary phase. So the object's no longer moving and it's staying at the same position for an extended period of time. Now there's no numbers on this graph, just to make things a bit more simplified, but of course if there were numbers on it, you could count along and see how many seconds it took for that object to move the first point and also stay stationary. So that word stationary is a really key idea that you need to be aware of. Then the object starts to move again, but at this time, the gradient is less steep, so it moves slower. And then it's stationary again for a shorter period of time. And then as you see, the line goes back down to the start, and that tells you, because it's gone from a certain distance back to 0, the object has actually moved back to the beginning. And that's some of the key ideas for this particular type of graph. And that's it from me today. I wanted to just say a massive thank you to everyone's support here on my channel and also on my other social medias. It's so lovely to have so many of you who are wanting to learn science and get a better grade. And thank you so much for all your kind comments and just general support. It's so lovely to have so many great people here. So thank you ever so much. I've been the GCSE science teacher and you have been curious. I hope you enjoyed this video. If you did, feel free to subscribe, like the video, share it if you would like as well. And I will catch you in the next one. Take care.